When gases like sulfur dioxide and nitrogen oxide are emitted into the atmosphere, they react with water, oxygen, and other chemicals to form sulfuric and nitric acid. And when these acids precipitate, we get acid rain. Acid rain can kill trees, plants, and fish, as well as erode automobile paint, buildings, and stone. The Clean Air Act amendments of 1990 introduced a novel way to combat acid rain: tradable permits. Whoa. Here's how they work. Let's consider two power plants or factories that are polluters. They emit this much polluting gas. The government could control pollution by just commanding that all factories install certain technologies, like scrubbers. Using this command and control method, suppose that pollution would be reduced to this. Okay, but now imagine that one of the plants can reduce pollution at a lower cost than the other. Perhaps it's newer, or it uses a different type of coal, or maybe there is some other technology for reducing pollution that the government didn't consider, or perhaps the product produced in one of these factories has a less polluting substitute that we can easily switch to. Ideally, we want to reduce pollution here, where reducing pollution has a low cost, and less here, where reducing pollution has a high cost. If we do this, we can reduce pollution by exactly the same amount as before, but we can do it while wasting fewer other resources. Great. But wait, unfortunately, the government doesn't know which plant is the low-cost plant. Remember, there are lots of ways of reducing pollution, lots of substitutes, and lots of substitutes for substitutes. No one person knows all the trade-offs. Information is dispersed. So how can we draw on this dispersed information and harness the energy of entrepreneurs to discover the best ways to reduce pollution? Instead of commanding how to reduce pollution, suppose the government issues pollution permits, rights to emit pollution. One permit gives you the right to emit, say, 1 ton of polluting gases. Pollution permits don't sound very environmentally friendly, but the government only issues a limited number of permits, and that equals the same total reduced pollution as under command and control. So in the end, pollution reduction is the same. By allowing the permits to be bought and sold, the profit-seeking self-interest of power plant owners is harnessed for the social good. The owner of the power plant with the low cost of reducing pollution thinks, I don't have to use my permits. I can reduce pollution at my plant for less money than I can get by selling my unused permits and make a tidy profit.
Oh yeah.
Meanwhile, the power plant owner with the high costs wants to buy permits and is willing to pay a lot because it's cheaper to buy permits than reduce pollution at high cost. So, the power plant that can cheaply reduce pollution sells permits, and the power plant where it's expensive to reduce pollution buys permits. Both firms increase their profit. In this way, the invisible hand of the market gets us to the ideal solution. We reduce pollution more here, where reducing pollution is cheap, and less here, where reducing pollution is expensive. The total amount of pollution, however, is reduced just as much as with command and control, but at a lower cost. In fact, the tradable permit approach worked so well, it reduced air pollution at a much lower cost than any expert had anticipated. Why should we care about the cost of reducing pollution? Spending less on reducing pollution means that we have more to spend on other goods. But also, don't forget the law of demand. The lower price of pollution reduction, the more pollution we want to reduce. Tradable permits uses the invisible hand of the market to discover the lowest cost way of reducing pollution, and that's good for everyone. If you want to test yourself, click Practice Questions. Or if you're ready to move on, just click Next Video.